As said, my name is John McDonell. I'm from Engineering Design Consultants. I am the BIM lead over UK and Ireland operations, and I'm going to briefly describe a few case studies, two in particular, and just give you a brief outline of how we gained level 2 accreditation in the UK and Ireland. Just a brief on the company. We have locations in Cork, London and Dublin. We are about 38 staff at the moment, with recruitment of 2 more ongoing at the moment. So we're looking to have about 40 staff over the 3 offices in the next week or 2. Just a brief of our sectors. We generally do energy from waste, public buildings, schools, hospitals, etc. We've healthcare, local government like libraries and stuff like that. So we've quite a bit of residential again in the UK, which is high-rise residential and stuff like that. We also recently completed coordination of 3 data centres, with 1 ongoing at the moment, and it's purely M&E coordination of services within the data centres. So just to start off with the BIM Accreditation. We were the first MEP company in the UK and Ireland to gain accreditation. At the time, we went with Lloyd's Register, which BRE wasn't existing at the time, so Lloyd's Register had opened up the accreditation scheme, so we signed up to that. It initially started with a gap analysis, which was done in December of 2014, which basically they come out, they assess your company to see what your processes are like, and they tell you then what you need to improve on or what you need to implement for them to accredit you. That gap analysis was done at the start of December. They returned to our offices in January. They gave us a month to implement what we needed to implement, and then towards the end of January they granted us accreditation after they were satisfied that the gap analysis had been implemented. So the end of January we were accredited in 2015, and then like ISO 9001, your surveillance visits start from then on. So 3 years, you've a full audit again, but every year you have a surveillance visit. So we passed our 2nd surveillance visit, which was done in December last year. Couple of the items that they go through, and which are part of the accreditation, which need to be in place before you probably go for accreditation, which is your management support. So, as anyone will say who's implementing BIM, it has to come from the top. You have to have support from the top, and that was there. So the managing director was driving the implementation of BIM throughout the company, and like a lot of the speakers have said, there will be a lot of pitfalls, and you need support from the top, because with 38 people in the company, you're going to get different personalities, different problems coming up, and people not wanting to change. And I suppose it'll be repeated throughout my presentation, that's the way we always did it. Is kind of that attitude needs to change, and it does happen in your own company with electrical engineers and mechanical engineers wanting to keep things the way they were. You need to appoint someone who will drive it for you. Now, this person was me at the time, but over time and through the accreditation process, I need to be diluted, as in there needs to be another 2 or 3 of me and ongoing that need to, if time goes on, needs to take up the mantle of some of the stuff that I'm doing as well. So you need to appoint someone for lead it, but over time that person will be diluted into a couple of more people. The one step we took was, and people call it Lonely BIM, is just we 3D modelled everything. We just wanted to get our modelling right, our processes right. So even on jobs that came in 2D, we just done a 3D model for coordination purposes, M&E. That left us the ability to switch back to CAD if things went horribly wrong, and people went back to comfortably just producing CADs. Wasn't detrimental to the project still went out. So start modelling on smaller projects, get 3D modelling right, and that's half the battle. Gradual rollout of training to staff. Don't train all your staff at once. We started with 1 or 2, then a project came up that had a long lead in time. It was a 7-storey apartment block. So we took that project as a starter for 2 or 3 other modelers. There wasn't crucial deadlines on it, so we were afforded the time to get the modelers trained up on that project. Appreciation of different drawing tools. So it goes back to the engineers appreciating that you are a new drafting process, new drafting software. So there's going to be different outcomes. One issue that came up was grid lines were in front of one of our symbols, and the engineer couldn't understand why we couldn't send the grid lines to back. They just sent it back, wasn't in the program. So the grid line eventually was what you call it, half toned out, and we done our best to try and get it to go to back. But simple things like that were available in CAD may not be available in ArchiCAD or Revit or any of those. So the understanding that you couldn't do something in the package was a big learning outcome of the engineers and that. So changed drawing standards to BS standards. So we had our own in-house drawing naming convention. We very quickly realised, look, we're getting more and more models in with the BS 1192 or the 2007 naming convention. So we switched to it, because if we're sending drawings out, it's just showing that we're willing to implement the standards. We're trying to align with everyone in the UK and Ireland that are implementing these. So it just makes things easier between coordination between some of our colleagues in structural and architectural. And we also took the decision early on just to implement our own common data environment. The main reason for this was just for our own revision control. So instead of having our two drives or drawings out drive, we implemented an external common data environment which now does our revision control, which we send out automatic transmittals from, which is sending out the latest version. So our engineers going to the site can just pick on the latest drawing, download them to the iPad, and they have all the PDFs on their iPad, can look at it while they're on site or in design team meetings. And I suppose the last thing was you have to run a BIM project or two in your office to go for the accreditation, so that you knew where to go for what they were asking. So if you had a common data environment set up on another project, that if they asked you a question, how do you do this, you were able to go and show them. So during the accreditation, these were the points that they went through. So the organisation structure was the first thing, which assesses any changes to company BIM structure, interfaces, and it sees like if you get a BEP in, who is going to implement that BEP on the project. So like I say, initially it was me. I was reading through BEPs and setting up the projects as the BEP set out. Now we have 3 or 4 guys doing that on their own projects. So it is, and throughout the accreditation, it is to minimising risk on, let's say, one of those staff members leaving or something like that you have a dilution of the same skills throughout your company. So in essence, what we're gaining for is everybody in our company gets up to BIM management level. Some may not want to go that way, but we'll just assess them on their skills, and if they want to stop at a level, that's fine, you know. But you have to assess every individual on their basis. So that leads into HR. So you have to do what's called a skills matrix. So, for instance, if we get a BIM project in that's on a site, there's no point in putting someone that has no experience of a site, which is the common data environment on that project. You look down through your skills matrix and you spot a BIM manager that has a lot of experience on a site. Simply so with you know, healthcare projects, if somebody has done all data centers, you know, somebody with that or healthcare experience is probably a better BIM manager for that. So it's to go down through the skills matrix and pick your BIM manager is all that the HR and competency matrix goes through. So the next point was configuration management. So it's just, you are getting all information in, so if something goes wrong, it's how do you in a company review all those actions. So through our company, it was through management meetings. So if something came in on a big project that needed to be relayed and implemented throughout the company, you need a forum to implement them across your management structure. So it's again down to how, let's say, clash detection comes in. How do you filter that down to the guys that are actually doing it? So you have a lot of project managers going to meetings, being asked why isn't this clashing. So you need a company structure down to see who is taking care of this and who has responsibility for it. Procurement and subcontracting. So if we use anybody externally, we need to have our subcontractor competency forms in place so that we can send them out to be filled out by the subcontractors. Generally speaking, in M&E or consultancy, we don't use many subcontractors, bar a point cloud surveyor or something like that. But again, they'll have all them filled out and kind of standard enough document. Risk identification, assessment and control. So again, that's just having all your risk registers in place. So not only BIM risks, but also company risks they look at in the accreditation. So in a particular BIM project, if you've come up with a problem like uploading documents or something like that you're actually recording the problems on a project and having a register of those, and then you need to come up with mitigating actions to make sure that they don't happen on the next project. But again, that needs to be relayed to everyone. So you need a common environment and a common forum to discuss them throughout the company. So they look at your how you actually portray that across the company. Process control and BIM. So again, process control, how you control on a pre and a post BEP, how they are kept up to date. So if we are asked to quote for a project, obviously a project that we quoted maybe 2 or 3 years ago would have different standards. Back then, like BS 1192 has been updated in 2015 and 16. So just to be sure that our BEPs are representing the version control and making sure that they're changed to the latest standards. Then the accreditation sees who that person is, that makes sure that that's kept up to date and where it's kept up to date and where people can find it within your company. And then the last thing was performance monitoring and improvement, where EDC can review findings and sorry, that's after moving on there. So the findings of the report, where we review the findings of the report and where we discuss them and record them and make sure, again, that any non-conformities are taken care of and processed throughout the company. So that's a brief overview of our accreditation and what we had to go through to gain it. Some of the case studies I want to go through is EDC as a Cork company and stretching out further field is the winning of work abroad through collaborative BIM, which is a huge export industry, what we are after finding. So through working through our Cork office, our London office and our Dublin office, we're winning work in places that we may not have won it before. So through a marketing drive in the UK, we managed to team up with a Nigerian architectural consultancy who were also Rivet enabled. So just through back and forth, we decided to collaborate them on a project. So first project we collaborated on was a 250,000 square metre office block, which is the one on the left of the screen there, which was 16 stories high, I think. Then out of that, we won a second project, which was another office block, which was double the size, which was nearly 42,000 square metres, but included a convention centre. So we were being exposed to projects that we, may not have come up that often in the separate market. So we were gaining experience through a company of projects that don't come around that often. And then the last project was fire engineering on high-end residential, which is the one on the right. So I'm just going to briefly speak about the second project, which was the largest one, was for 42,000 square metres office block. It consisted of a convention centre, exhibition area, multi-storey car park. It was just done over collaborative video conferencing. So to deliver this project, everyone must buy into delivering the project efficiently. Huge change in attitude with modelers and engineers solving problems together. So there was a disconnect before with modelers thinking they were CAD people and engineers going to design team meetings. You have to get rid of that disconnect. Modelers need to be involved, knowing what's going on in the project, so that you're getting a better product at the end of it. This was all done over video conferencing. For the first project, I think there was one trip made to Nigeria. The second project, there was none, so it was very efficient. We didn't have to go to site that often. We just done a few things which were basic requirement in BIM. So a common data environment was used, so we used our own in-house common data environment. We granted licenses to the architect in Nigeria, and we shared the model every week. Then every Monday there was a weekly coordination design team meeting, which modelers sat in on, and were kind of kept up to date with what changes, and understanding that what they're actually modelling is actually going to be sent out to tender and probably built on site. So getting an appreciation that they're not just drawing lines or pipes on a page just to get out a drawing, that they're investing in the project to know that what they're doing is actually a physical piece of equipment or component on site. Clash detection and resolving. So we done clash detection. Clash detection was handy for us negotiating with the architects for riser space, because again, an MEP engineer has never left enough riser space or ceiling void. So we were able to show them, which was alluded to before, that ceiling space was important, and where we needed more ceiling space or maybe needed more riser space. Kobe was not a requirement on this, so it was just purely level 1 BIM, I suppose, more or less, as in they just wanted it to be coordinated, that the building, the model to be right, and that they wouldn't have any problems on site. So that was fine. New opportunities, the learning outcomes, new opportunities to win prestigious projects abroad. So worked out very well for us. We realised that this could be done. We could be employing 10 people in Cork, delivering this project at the height of it. Could accelerate the company growth. So again, a couple of projects like that will keep a good few teams going of mechanical electrical engineers and a couple of modelers. It demonstrated that collaboration through sharing of models on weekly video conferencing works during the design stage. It was hugely efficient. Like I said, there was only one trip for the first project, and there was no requirement for trips over for the second project. There has been subsequently, because it's now going to tender and it's going to site. There was a few tie-ups in London when the architect might have been in London, but that was it. There was no extra expense or anything like that, because it was in our offices in London. Clash detection was critical in negotiating risers and ceiling voids. Again, like I say, a lot of time MEP engineers are the last on the design team, and we're more often than not just given a drawing and saying coordinate that, fit it, but not that doesn't work all the time. A requirement on this job was that from the model we had to do a bill of quantities for tender stage. So we were able to pull off the bills of quantities fairly easy for the architect, and which formed part of the tender. Lack of local regulatory documents. So yeah, they kind of implemented BS standards on this throughout. So it was tough to see if there was any local Nigerian regulatory documents that we needed to comply with, because it was kind of hard to pull those documents. The second project I'm going to talk about is a sports arena, which we secured for the contractor as their BIM managers. So first, it's two buildings. It's called a dry and a wet sports. Dry sports is a gym for a rugby team, and the wet sports then is a deep diving pool. So it was a 25-metre pool. Interesting with the pool is it's got a retractable floor, so the depth of the pool ranges from 4 metres to 1.2. Specialist gym area for professional athletes, which is the dry sports, ancillary changing rooms and team meeting rooms, etc. Level 2 is a requirement on this. So BIM management of architectural structural MEP models, common data environment to be fully utilised, 4D bi-weekly model updates. So through the programme we had to demonstrate what was being done for the next 2 weeks, just as a kind of continuation 4D model. Kobe populated model, and then an asset information model was the deliverable at the end. So we're I suppose nearly halfway to 3/3 of the way through that project at the moment, and I wanted to come up with the learning outcomes so far. The project hasn't been completed yet. I suppose the learning outcomes is the project wasn't originally conceived in BIM, so it was a contractor requirement to deliver a model. A lot of the time it's hard to wrestle a model into BIM if 2D was the deliverables at the time. So we had received one half of it, which is dry sports in level of definition 4, which was the end of the design, so the contractor had to take that up, and the wet sports wasn't delivered in BIM at all. It was a very standard model. So suppliers, again, this is constant battle is trying to find components and the actual components that are being installed. So suppliers, contractors, subcontractors not fully equipped or have understanding of the importance of installing to the model. So you take the large contractors who are implementing BIM, like BAM and the like, they find that they've BIM guys on site, but the guys that are building these types of buildings, which will be the next tier of contractor, a lot of them don't have the in-house capabilities or the ability to drive it. So, and then on top of that is their subcontractors have even, and a lot of the time have less of an ability to do it. So it is still a constant problem. So again, the attitude of, sure, that's the way we always did it, it comes through in everything we do with the lower end contractors, as in like pool filtration system in this. Sure, that's kind of like the tank we're going to use, but that's not good to me. We need the tank that we're going to use. That kind of thing. So a lot of suppliers still are behind in the times for producing models of their equipment. A huge problem which arises is the constant updating of the common data environment. So trying to get an electrician who, this is his first BIM job, saying the importance of uploading your tech subs of the equipment that you're using, the distribution boards or whatever that you've procured. We need all details of them. We need sizes. We need what's in them and all the details of them. It's difficult to keep them disciplined in always updating the common data environment. Challenges in presenting coordinated model to site. Personnel highly detailed 2D coordination drawings required to present the model intent and reduce remodeling. So we had to put a lot of effort into doing coordinated services drawings and setting out the model so that the contractor would install to the model. And it is extremely hard in doing containment, pipe work, duct work, all to bottom of the pipe, bottom of tray, bottom of duct, and presenting that to site, and saying to the contractor, you must install this because this has a knock-on effect throughout the building. So it is to try and keep them disciplined to coordinated drawings. One of the things I tried to do, because they weren't BIM-enabled, again, we tried to give them a model on an iPad. So if they didn't understand a coordinated services drawing, that they'd throw up the model and say, oh yeah, that's what he meant there, as in if a dimension was missed or a bottom of pipe was important at that particular location. Mechanical contractor, I think, is decent enough on using the iPad, but the electrical contractor only purchased an iPad there a couple of months ago, and I'm not sure if he's logged into the system yet, but it's to get the discipline to use it. The technology, the tools are there, but again, they have the tools on site and they're still not using them. So when I go to site every 2 weeks, you'll see stuff and you'll be requesting red lines off them. Then why did they change this or whatever? Now, not much has changed from the BIM model, to be fair to them, but there are some extra trays coming up somewhere in parts of the buildings. Vastly improved accuracy of builders' workscopes. So there was a lot of fair-faced concrete in this project, where a big atrium in the middle, so builders' works had to be highly accurate. Through coordination, we delivered the builders' opes, which have been filled, and none have been excessive or not used or extra required. So there was no facility to core out on this central atrium. It was fair finished, very highly finished on it. Program of service installation improved with greater visualization. So the program started to slip, so the contractor started to use the model to say, well, look, why can't we go into this area? If we build this area up now, we can shove the mechanical engineer in, or mechanical contractor in there to finish out that area quickly, and at least that's one place we can start to pull the program back. Less overtime or less downtime on site, problems we raised early and resolve within the model before they manifest themselves. I think that's a common recurrence within the process. So just a quick learning outcomes generally on M&E services. So this is traditionally the way the MEP services would have been coordinated, which is a CAD layer over a CAD layer. And it's poorly coordinated. It's just a CAD operator just overlaying XREFs. A lot of the time, the CAD guys wouldn't have been experienced with working drawings or site visits. So what we tried to do is we tried to bring the lads along to deal with the contractors direct, so that they get the experience of dealing with somebody that's actually going to be installing these. So some of the issues, let's say, of coordination was, and what we see sometimes is we're getting in models that actually can't be constructed. I think there's a huge emphasis put on a clash-free model, and like if you say to a Revit modeler, I need a clash-free, well, they're going to stick it anywhere that it's not clash-free, even though it can't be constructed. So there's a huge issue with it being clash-free and constructible. So in an instance here where you've cable tray over a bank of pipes, with the cable tray only 50 mil from the underneath slab, there's not an electrician in this world will get his hand in there to pull a cable or anything like that. So it's critically important that your modelers or your CAD guys have experience of how stuff goes in on site. So this corridor is one project that we got, which was had to be coordinated to something like this. So it's just again like that experience of like, yes, the model has to be clash free, but it also has to be constructible. So this is what the model ended up looking like, and that becomes more apparent within 3D plant rooms. So if you 3D up the plant room, you put someone in the plant room that's going to construct it. Quite quickly, they're going to see any problems. And I suppose we've kind of developed. I know Oculus was mentioned, but we went with Samsung Gear because it's just more movable for us. So it's any model that we do, we do have the facility to give the client a virtual walkthrough of it, so they can go in, they go into the plant room, they can see if pump sizes are too high or pump heights are too high, or if they can get in service zones, stuff like that. It just gives us feedback from a construction manager back to our team, so that the guys are becoming virtual site people more or less. Few kind of I suppose learning that comes from using VR gear is, like, granted you can look at a Navis model, but when you're in the model through a headset, you just get better depth of field and a better sense of space. Equipment proportions, which you might not get in Navis, is just how big a tank might be, and peripheral vision, what might be around you as you're walking through the model. The other thing is better viewing of the model, faster review time, and enhanced client sign-off. So you might need to get sign-off from a client who's never seen a drawing in their life, but if you put them in the model, they can tell you where they want something, or whether it works best. One typical example would be, let's say, nurses and heads of hospitals may not always see drawings, but they're the ones that are going to be at the bed head. So put someone in the model, show them the bed head, say, look, oxygen is there, vacuum is there, no, change it around. So it just gets faster sign-off from various parties who are going to be using the building. Another thing is constructability, better maintenance, high restructure, service and equipment supports. And I know I'm running out of time here now, so I'll quickly do this. So a lot of things was the builder's works. So if you model something correctly, the builder's works are hugely accurate. So on the left is a model of builder's works, on the right is being constructed. Then this is the corridor with everything. On the left is the Revit model, on the right is it being constructed. So if the contractor follows what the model has done, what's been done in the model, you have great, it's like, great outcomes for the project and timeline. Again, with plant rooms planning, just again sticking somebody who's going to build that plant room into it to tell you is if they can build it this way or not. And grilles and louvers, just this, we punch holes in the side of the building that the architect hates. So it's just to give the architect an opportunity to see where we're punching the holes in the side of his building, tell us to line it up with whatever. So as an M&E engineer, normally we just go from A to B. So if we go to A to B to C, which looks better on the outside, then the architect is happy. And that's about it. So thank you.